Okay, what we're doing today is we are talking about Chapter 9, which is re-expressing the data. For Chapter 9, it used to be talked about a lot more in AP Stats, and now it's kind of a little bit looser, and so we're only going to highlight some things and then really just do some math with it. So there's some goals to re-expressing data, and you need to be aware of this, like why do we want to re-express data? And so for histograms, the goal of re-expressing data for histograms is because we know how to describe histograms that are unimodal and symmetric, because then we can apply the normal model. So for histograms, we want to make them unimodal and symmetric. So that's why we are going to re-express histograms. And so re-expression means like you take the log of all the numbers, you square all the numbers, you multiply all the numbers. That's re-expressing. You're doing some kind of math operation. For box plot, the purpose for re-expressing box plot is we do things to make the outlier smaller and to make the box bigger. Golly, I've not written this pen in a while. My handwriting is atrocious. Okay, and then for scatter plots, our goal for scatter plots is we know how to talk about scatter plots that are linear. And so we want them to be linear. So we want to make it linear. It used to be that we would have to actually learn how to straighten it and how to find the best model, but that's no longer really covered in the AP statistics curriculum. So instead, we're just going to learn how to talk about why we want to and then do some math with it. Okay. Once you re-express things, when you're doing it, you actually recheck conditions to make sure it works. God, that handwriting's horrible. Okay, so when we re-express things, there's some things that we have to say about statements. And so one of the things we might do is when we re-express, we may take the log of x, but our y stays the same, or maybe we're going to take the square root of y. So it would look like this. Okay, so whatever you do, you have to include that in your sentences. So if I take the log, I'm going to have to talk about the log of x, not just x. And if I take the square root, I have to talk about the square root of y, not just y. Okay, so let me write this so you can kind of see what I'm talking about. So the difference, and it's usually the difference in x, but now it's going to be the difference in the log of x, and whatever x is as context accounts for r squared percent of variation, and not y, but variation in the square root of y. And so again, because I was doing y was the square root, I had to say square root. And because I did the log of x, I just had to include the saying log. Okay, so whatever you do to the x or y, you have to include it in your statement. All right, residuals. When you look at the residuals again, or you talk about the residuals again, you focus on the ones. Why is my handwriting so bad? Hold on. So when you talk about residuals or look at residuals, you're not looking at the residuals from the original one, you look at the one from the new model. And so when you use the new model after re-expressing things, it actually gets random and the residual plot gets random. Okay, so we're going to do a couple problems so you can kind of see what you have to do. You are not going to have to come up with these equations. You're going to have to interpret the equations and you're going to have to be able to use the equations. So write a statement about r squared. Remember, r squared is the difference in x accounts for r squared percent of the variation in y. And so what happens here is the big difference is that it's not just population, it's the square root of population. So see if you can model your answer for number 1 similar to what we did up above, and then when you think you got it, press play. Okay, I'm no longer going to try and handwrite my sentences because it's horrible. So for this one, the statement about r squared, the difference in years accounts for 99.3% of the variation in the square root of population. Because it was a square root of y, that's why I do that. Okay, so now here I can write math. So with our math, we're going to plug in 2005. So I'm going to show my math. So it's the population square root hat. And then you remember you have to show this step, all those numbers of plugging in. And then I'm going to plug in here. And so now I have pop hat square root, and then I need to figure out that answer. Okay, so when I plug it in my calculator, I get, hold on, my calculator, 1,496.59. And now we just have to solve this. So to get rid of a square root, you have to square both sides. And so now my population, I'm going to take my answer, I'm going to square it. Oops, square 2. And so it's that really big number. So let's see. So 2, all right, you're writing 2239785.37. And so 2,239,785. So when you have these problems, you have to think about how to solve things by using algebra and using the inverse operation. Okay, so why don't you go ahead and try number 3, and then we will come back and check your work. Okay, so you plug in 2010, and you get 1,500, and then to get rid of a square root, you square it. Okay, so now interpreting the slope, and so remember slope is the change in x, or the x goes up and down. So, so your y is population. But it's not just population, it's the square root. Okay. So the square root of population increases by the slope 0.7457 each additional year on average. So again, because I have the square root of population, that's my y, I had to include that in my statement. Okay, so now what we're going to do is we're just going to do some practice finding these. And so these are a couple problems you can do on your right side. It's really just because some of you haven't had to do some of this stuff in a while, the algebra, and I want to make sure we understand how to do it. Okay, so let's do this one, this first one. I'll make it look better. Let's do for time is equal to 23. So what I do is I just plug it in here. So it'll be the log of bacteria equals 1.56 plus 0.45 times 23. I can plug everything in the right in my calculator, so I'm going to do that. So 1.5, oops, that's not my calculator. 1.56 plus 0.45 parentheses 2, 3, and I hit enter. And so I have log of bacteria equals 11.91. Now, some of you might have been good with logarithms and remember how to solve them, and there's going to be a handful of you that don't. What's nice is you don't have to remember. You just have to know to get rid of things, you do the inverse. And our calculator is super nice because log is right here. Where's log? Log is right here. The inverse of log is second log. And then you just go get your answer. And that's how you solve. To get rid of something, you do the opposite. I'm not going to get in the algebra. Just know that you do the opposite. So you hit second log. And so that is my answer. And so it's going to be bacteria hat is equal to 8.13. And you see this E, remember that's times 10 to the 11th. Oops. There we go. Okay. And so that's the answer. So again, you plug it in, you find your answer, and then to get rid of a log, you hit second log. So to get rid of something, you do the inverse. All right, same thing right here. Let's try this out. Let's say this time the length is 0.13. So I would like you guys to go ahead and start this off by plugging it in and see if you remember how to get rid of a third root. And when you think you have it, press play. Okay, so you have to show that plug-in step. You don't have to show any of the other algebra, but you got to show that. And so I get 4.08156. And now I have to get rid of a third root. Well, up above we got rid of a square root by squaring. So to get rid of a third root, we're going to go to the third. That one's not the inverse. You have to know what that one is. So to get rid of a third root, you third it. And so then now I just bring this to, that's my caret key, to the third. And there's my answer. So my predicted bacteria is 67.995. So I would probably round that to 68. So again, you plug in, and then you do the inverse, and the inverse of the third root is the third power. All right, one last one. Okay, so let's see if we can find it with a distance of 50. So go ahead and plug this in, and then check in when you think you got it. Okay, so to plug this in, you just plug it in, and then you hit the log button. So I did 0.61, and then I hit the log button, and then 50. So I plug that in, and I get 1.75. And remember, to get rid of a log, I hit second log. So I hit second log, and so second log, and then I go get that answer. And I hit enter. So then my predicted bullseye is 57.06, so 57.1, or actually 07, if I'm doing to the 10th, to the 100th. Okay. So for this chapter, you have to be able to plug things in and kind of solve them, and then you have to understand why we want to re-express. And that's it.